Three new standards are trying to answer the same question. How do AI agents operate on chain? We have ERC-8004, gives the agent identity, x402, and MPP then gives them the ability to pay. But none of these actually solve the hardest part. What happens after the payment is signed? Who guarantees that the transaction actually lands? And that's the missing part that I want to break down today. And the best way to do that is by starting with what these actually do. So if I scroll down here, we'll start with ERC 8004, the agent identity. Who is the agent? The registry here lives on Ethereum mainnet. It went live in January of 2026, and it creates three on-chain registries for AI agents. An identity registry, which is basically a directory where the agent gets an ERC-721 token linked to the metadata. And in that metadata, you have things like name, endpoints, and wallet addresses. Then we have the reputation registry, where clients and other agent records ratings after interactions with said agent. And a validation registry, which answers the question, did this agent actually do what it claims? The authors of this framework are from MetaMask, the Ethereum Foundation, Google, and Coinbase, so it does have a lot of institutional weight behind it. But notice what it doesn't do. It tells you an agent is, like who an agent is and whether you can trust it, but it doesn't actually move the money. And that's where we can then move into the other layers that we have here. The first one, x402, which is Coinbase's payment layer. And this protocol is HTTP native. And what that means is it uses the HTTP 402 payment required status code. And that's been reserved way back since the 90s. Basically, an agent will go ahead and request a resource, and the server will then respond with a 402 plus payment instructions in the header. The agent then signs a payment and retries. On the side, you also have Coinbase runs a facilitator service that handles the verification and settlement as well. X402 is blockchain agnostic, so it will work on Base, Polygon, and Solana. It also goes ahead and actually settles each payment individually, and of course, this is on-chain. Then we have MPP here, and MPP just launched recently in March of 2026, and it does the same thing but differently. It also uses HTTP 402 as a trigger, but the payment mechanics then go ahead and diverge a little bit. MPP uses something called IETF, which is the payment HTTP authorizations, HTTP authentication scheme, where X402 then instead settles it per request on chain. MPP then instead batches multiple requests via like session keys, and then it will go ahead and stream these micropayments off chain. And then in the end, it will actually go ahead and batch thousands of vouchers into one single settlement. And this will be on Tempo's chain. Speaking of Tempo just launched March 18th of 2026, and it's backed by Stripe and Paradigm, and also has design partners such as Anthropic, OpenAI, MasterCard, Visa, Shopify. So you can see kind of the direction where you have two very big institutional backings on both sides, pushing for their payment protocol to be, the go-to on chain. So maybe to kind of summarize that, X402 is open web per request, multi-chain, whilst MPP is high frequency, it's batched, and it's Tempo native. There's trade-offs between the two, but essentially, they have the same goal, agents paying for things over HTTP. Now, the gap here is still that none of these actually solve what actually happens on chain. And that's the gap that I want to kind of dive a little bit deeper into. And the best way to do that is kind of looking at the stack today. We have it as it's emerging at the top, the agent. And this is the reasoning layer. So here we'll have the likes of Claude, ChatGPT, Gemini, basically your preferred LM model or reasoning layer that you'll be using. Below that, we then have the identity layer from the ERC registry. And this gives your agent a verifiable identity. Then we have x402 and MPP for the payment. But between the payment and actually the on-chain settlement, we have the execution layer. And right now, this is where things often break. So think about it like what happens when an agent is managing a DeFi position that detects a liquidation risk. It decides that it wants to repay the debt. It authenticates via the identity layer. It pays for the execution service via x402 or MPP, or that works fine. But then the actual on-chain transaction, when it comes to repaying the debt, it fails. It could be that gas spiked, the transaction got stuck in mempool, a solver dropped out, the state changed between the simulation that was before and the actual execution. The identity layer did its job, payment layer did its job, but nobody actually guaranteed the transaction would land. And that's the execution layer as we define it today, and also what is missing from the stack. So I can't leave on that cliffhanger. I'd love to kind of showcase where we see us, KeeperHub, fitting into sort of that stack. KeeperHub sits right here, so between the payment layer and the on-chain outcome. What you'll see now is that KeeperHub will actually do a simulation before execution, but every transaction will also get simulated against current chain state before it's submitted. So if the simulation fails, the transaction never hits mempool. The agent gets told why and can decide what to do next. This could have solved a lot of different disasters that have been happening over the past few months. But beyond that, there's also a lot of infrastructure support in the sense that we have retry logic with gas optimizations. We have, if a transaction gets stuck, KeeperHub doesn't just wait around. It retries with intelligent gas adjustments, whether it's like exponential backoff that adapts to network congestions, or just being able to slowly increase the gas fee to make sure that the transaction actually lands. And in a maturing Web3 market, it also comes with a full audit trail. So every agent action is actually logged, whether it's a trigger, the simulation result, the submission, outcome, timestamp, all of this information is fully logged. So when an agent is making hundreds of thousands of autonomous payments per day, you'd like to know kind of what is actually happening, what happened, when and where. That whole audit trail will actually then also be able to be fed back into the registry, the reputation registry, as sort of validation, verifiable proof that this agent did what it was supposed to do. This here is KeeperHub Hub. This is right now where you can go ahead and build and manage your workflows. But here's where it's actually going. So imagine you have a DeFi team and you've built this yield optimization bot or strategy, if you will. Today, what you then do with that strategy is you probably write a bot and you'd host it on some server and hope that that bot then keeps on running. With the hub, instead, you can publish that strategy as a workflow and it shows up in the hub for any agent to discover and call. So the use case is that an AI agent wants to optimize yield. It will then naturally go ahead and query the registry and ask it who can optimize yield. The registry will point back to KeeperHub MCP's endpoint with capabilities listed per workflow. So the agent will see the yield optimizer workflow and it will check the reputation registry for that specific workflow and any other workflows it's considering. And in that reputation registry, it will look at things like past execution rates and also per workflow successful rates or something like that. All on chain and all verifiable as well. After a while, the agent will then decide, okay, I know what I want to use, and it goes ahead and then connects to the MCP keeperhub.com, searches again for those available workflows and calls the one it wants. When it's called the one it wants, it will pay an invocation fee via x402 or MPP, And the example I've used here is that it'll pay 10 cents per execution, probably a lot less. And 7 of those will go to the creator of the workflow and 3 will go to the platform. And the only thing that the creator is actually doing, they're not running any infrastructure. They're publishing from the dashboard hub that I showed before. KeeperHub will handle the execution engine, the simulation, the retries, the gas logic, the audit trail, the SLA, and everything else in between. But with this, every successful execution adds a positive signal back to the reputation registry that you see here. So over time, the most reliable workflows in the industry will rise to the top. So we don't just have these no-named workflows or the agents creating, workflows that aren't verifiable or that aren't audited or that aren't backed. And in the end, you'll actually end up with a marketplace where workflow creators can build strategies, agents can discover them and pay for them, and KeeperHub can then execute them reliably and essentially build the reputation layer that that will make the whole thing work. That's the model that we're building towards. Creators publish again, agents discovers, and KeeperHub executes. 3 standards are being defined right now on how agents will interact on chain. ERC-8004 for identity and trust, x402 and MPP for payments, and what's been missing all along is the execution layer that ties them all together. That's KeeperHub, and not just the engine that lands a transaction, but also the platform where the workflows get built and discovered and are also paid for. That's the stack that we're working toward, and also right now it's completely open for builders, so we hope to see your contributions to this execution layer in the near future.